Thank you, everyone. Good morning. How's everybody doing? Yeah. All right. Hey, surprisingly awake for the second day this early in the morning. Thank you guys so much. It's a pleasure to be here. I've already started that. Thank you. I'm Jeff Woolsey. I'm a Principal Program Manager in the Windows Server, Cloud, and Enterprise Division. And with me, I've got Matthew John. Matthew?
I'm the Group Program Manager for Hyper-V and Containers. I'm from the Operating Systems team.
And I'm Madan. I'm a Lead Program Manager in Azure.
So one thing I want you to see right off the bat, I'm really psyched about this because we actually have Server, CoreOS, and Azure here all together. And if there's anything we've been talking about for the last few years, it's how we've been thinking about cloud very holistically, public-private service providers, how we bring all of this together, and how we're working so closely in lockstep. This is a pretty good example right here. I'm very psyched about doing this session. Today we have platform vision and strategy, next generation computing with server virtualization. A couple things to just point out in terms of kind of where we are in terms of the sessions and what's happening at the conference this week. Just kind of give you an overview of some of the sessions real quick. In terms of an overview perspective, we have the Azure Consistent Service Delivery overview. Today, right here, we're doing the data center, the virtualization overview. So yesterday, we did the Azure Consistent Delivery overview. That was one. And so today, we've got data center virtualization. We've got networking and storage and security and assurance. So that's kind of giving you that second layer right there. And then in number 6, what's new in System Center for Management, and 7, Linux on the Microsoft Cloud Platform. So to just kind of give you an overarching view of kind of how the flow kind of works, so you can see if you want to participate in that flow. If you see something you want to drill into, you can do that as well. But just kind of see kind of how this fits in the overall delivery. So part of the agenda today, the agenda we want to go through today is kind of, first of all, where are we in the data center evolution? In the past we've talked about, I remember when virtualization was new and the hot thing, and we are so beyond that now. Well, where are we now, and where does cloud fit, and where, honestly, are you, and where does all of this fit together? Which takes us to cloud. Concerns versus opportunities. I know when we first started talking about cloud, everyone kind of, there was a lot of concern and a lot of trepidation. Like, what does this mean to me individually? I'm used to being a storage guy or a networking guy or a compute guy or whatever. What does that mean in the cloud world? Well, people are finding out it means really awesome things. And if you saw the keynote yesterday and you saw what we're delivering and with Azure Stack, you just realized, oh my gosh, we're bringing those cloud technologies to you to run in your data center. So I hope you're realizing just how awesome that is and what we want to go on to this journey together. And one of those challenges is how to learn to take back control from shadow IT, which is, when your customers in your organization, say, you know what, I'm just going to go around you. I'm going to bypass you. Because honestly, at the end of the day, that's actually one of the biggest problems. Everyone gets a little too caught up in some of the other ones, but this is actually a real problem. Because now, who knows what's going on? How's that data being controlled and managed? And how do you help combat that? And so we want to talk about a number of these different topics today. So if we kind of look back, kind of where we've been and where we're going, and just really quickly looking back, Server 2008 R2, System Center 2007, this is really when we introduced virtualization. Okay, it actually isn't that long ago. But that's when Hyper-V, we said, no, this Hyper-V is a core part of the platform. We said, nope, hypervisor-based virtualization is there. Server 2012, we said we're moving beyond that now. In 2012, we said, look, we want to understand what are the things that are holding back key mission critical applications. I want to run the biggest, baddest SQL out there. I want to run the biggest, baddest SAP, Oracle, those mission critical scale-up workloads. And we basically said with the 2012 and 2012 R2, we don't want there to be any excuse for you not to be able to virtualize any workload. And pretty much done deal. We don't have anybody. I don't get complaints saying, you know what, Jeff, Hyper-V VMs are just simply too small. I can't get my work done anymore. It didn't happen anymore. Okay? With the advancements we made in live migration, unlimited concurrent live migration. We can perform the fastest live migrations on Earth with RDMA, SMB direct, compression, all of these technologies. This is already old hat. This has already been shipping. We made huge advancements in scale-out file server, bringing down the cost of storage, making it easier, more ubiquitous using mainstream hardware. We also embraced SANs. We did a ton of capabilities in SANs that a lot of people have already forgotten back in 2012. Trim, Unmap, ODX, a whole bunch of things that make Sans rock. But after 2012, people liked the scale-out file server so much they said, oh, we like that, keep doing more there. So we've been doing exactly that. And from a networking standpoint, a lot of people don't realize it, but we were the first ones to ship network virtualization. Spoiler alert, that was back in 2012, 2 releases ago. So we've been doing a lot in 2012, and in 2012 R2, we shifted it to be more of a, hey, you know what? Azure's the design point now. Okay? This is one of the reasons we got Modern up here. It's like, look, we spent so much time, we go to Azure guys and say, what is it you need to be massively successful? What are the features and capabilities that we need so that Azure can drive the next generation services, the next generation applications? And so that's kind of where we've been with 2012 and 2012 R2. And honestly, I don't get asked about the checkbox war anymore. And you know what I mean by the checkbox war, which was, way back in 2008, it was like, well, Jeff, does Hyper-V have feature X because competitor has feature Y? And we need to know, we don't even talk about that anymore. I don't see those crazy spreadsheets of features anymore because that's all done. We're beyond that. Conversation's way beyond virtualization now. Conversation's cloud. Real simple. If you're still having the checkbox war, then you're in the wrong place in the maturity here. The real question is, where do you want to be in 3 years, in 5 years? Where does your organization want to be in 3 to 5 years? What we're hearing pretty loudly and clearly is, we want hybrid cloud so bad we can taste it. We're going to continue to run things on premises, but boy, you bet we want to take advantage of some of that really awesome stuff we see up in Azure. Give you a perfect example. I'm sure if you were in the keynote yesterday, there was a video that was new to me yesterday. I was truly profound. The one that talked about genome sequencing. It used to take over 2 weeks to do a single genome sequence. Cost, what was it, many, if not tens millions of dollars to do one, and it took over 2 weeks. Now we do hundreds of these a day, and it costs $6,000. Okay? It's more expensive to renovate my bathroom now than to do genome sequencing. That's mind-boggling. That's how far we've come. And so people want to be able to take advantage of these advanced cloud services, the massive scale that we deliver, and still make sure that I have the ability to provide those same services on premises, which is why I believe Azure Stack has resonated so loudly. I was just walking through the hall yesterday, and everyone kept pulling me aside going, oh my gosh, Azure Stack is exactly what we've been looking for. I can go tell my developers, write this app, and it works in both places. Everybody's thrilled. Dev's happy, test is happy, IT is happy. We're thrilled, because that's exactly what we've been working to develop. In terms of share, I get this question asked all the time, and honestly, it's something I seem to track less and less these days, because Hyper-V's we're just crushing it right now. Okay, and we start from back in 2008 when Hyper-V was first launched, but we've been pretty much on a hockey stick projection ever since. And to me, the biggest, this is one metric, but the other metric I see, and one that's pretty prevalent, is I believe it's over 85% of VMware users now all are using Hyper-V as well. The days of, hey, I only use VMware, I don't even see that anymore. Everybody's like, no, we got Hyper-V in there as well, absolutely. And a big part of that is because we want to make sure that we can be running with consistency and in lockstep with Azure as well. So we are continually, and we're going to keep the pedal down. We're not done with Hyper-V in any way, shape, or form. You're going to see that today. The other thing that's really critical to understand is when we look at kind of from an analysis standpoint of what's happening in cloud, Gartner is one of the leading industry analysts out there they have these things called magic quadrants. And I'm not going to bore you with these, but this is something that actually very important to businesses and decision makers to kind of understand, looking at a number of organizations, businesses, kind of where the technology is, who those technology leaders are, where are the stragglers, and where are they going over time. And the important thing is you want to be a leader, quite simply. And when you look at x86 server virtualization in the quadrant, there's actually only 2 leaders in the magic quadrant there. It's VMware and Microsoft. But if you then go to public cloud storage services, VMware's gone. Now it's only Microsoft and Amazon. If you go to cloud infrastructure as a service, again, it's only Microsoft and Amazon. And when you go to enterprise application platform as a service, Amazon is gone now, and it's Microsoft up there. So the point here is we're the only one leading in all four, and in fact, there's actually a couple more I could have added to this, but these are the four key ones. Because as Satya has been saying for some time now, mobile first, cloud first, it's absolutely real. Every day we get up, every single person at Microsoft gets up and says, how are we contributing to mobile first and cloud first? It's really that simple. It's a tremendous focus you're seeing across the company, and you're seeing with all three of us on stage here. In terms of momentum, we've seen, and there's a ton of case studies online. Just a ton of case studies. A couple things that I like to point out is that people are really loving the fact that we've done some things that have been pretty cutting edge, especially in the hypervisor. I mentioned live migration. You want the fastest live migrations? It's period, Hyper-V, hands down, there's no discussion. We support 10, 40 gigabit RDMA InfiniBand. And because it's RDMA, there's no CPU overhead. We can do 10, 20, 50. We've actually demonstrated 200 live migrations happening simultaneously. Period. End of story. That was a release ago. And we started that work 2 releases ago. And we're going to continue to drive those things. And again, you guys will get the slides. Case studies are plenty available, so I'm not going to spend much time on this. The thing I do want to point out is kind of this next slide, which is we want you. Hello. There we go. We want you to be at the center of application innovation. And this kind of gets to the notion of shadow IT. You're supposed to protect, you're supposed to manage, you're supposed to control IT. But let's all be clear here. Shadow IT is happening, and it's risen, and if you don't think it's happening, or you don't think it's risen, or you don't think it's happening in your organization, you just haven't found it yet. Because your users are already using Dropbox, they're using OneDrive, they're using web services, they're using Skype. Cloud is happening, okay? The question is, how do you want to bring it in? How do you want to embrace it? How do you want to manage it? How do you want to make sure you're doing the right thing for your company? And in very much, honestly, I was talking to Matthew about this reminds us of virtualization, where I remember back in 2005, when people said, oh yeah, this virtualization, this thing is cool. You're never going to run it in production though. It's cool for test dev, and QA will like it, and devs like it, but you're not going to actually ever run that thing in production. And now, the vast majority of new workloads are all created in VMs. That's just how we do business. So we're just we're watching the same thing tracking right before us. But the thing is, we want you to be the center of this change. And I think that's an important point we really want to underline here. We want to make sure you guys are right there, managing and helping and doing the right thing for your business as appropriate. So you're still accountable to your business for implementing policy and managing control, and we want to make sure we give you all the right tools in the toolbox to do it. A lot of companies will always tell you, hey, the solution is we're going to give you this hammer, and your solution is to always use this hammer. And ours is to say, no, we're going to give you the full toolbox with every spanner and every spanner size, every screwdriver, every Phillips, every hex nut, every Allen, and metric and imperial, and let you go to town and do the right thing for your business. So this is really an opportunity to rethink your data center. Think services, not servers. It's one of the reasons why, when we were doing the demonstration for Azure Stack yesterday, and I was showing off the cloud app, it was really cool to show off the different resources that are underlying it. And we want people to realize, it's not about setting up an individual server anymore. We don't even think about, hey, I've set up one server now. The old traditional way was this really super tight coupling. You buy this expensive application, you put it on, and you try to marry it, and you try to get the right drivers, the right memory, the right CPU, and do all of that. And it was expensive, it was vertically integrated, you probably put it on some gold-plated storage, and that's what we've been doing for the last couple decades. Now as we move to cloud, it's like, no, we're using mainstream commodity hardware that everybody's using it. We're using it on an infrastructure that is homogeneous, and it's been built to fail. We expect it to fail. This is one of the biggest differences between how we've been doing IT and how we're doing it now in this cloud-first world. In the enterprise world, you bought this really expensive storage rig, you put everything, you had all of these disks that you paid, extra for you paid extra for the more reliable disk with the more reliable firmware, and you did all of these things to make it work. And you hoped that and nothing would fail. In the cloud world, you expect a disk is going to fail. In fact, you put in mainstream SATA disks You replicate the storage everywhere. And you know when the disk fails? Yeah, we expected it to happen. Guess what? We've got multiple copies, and the software fabric is intelligent to just deal with the failure, let you know about it, and move along. And we're bringing those economics, that type of engineering, that type of architecture to you. That's what the Azure Data Center, that's what we've learned in running our Azure Data Center and why we're bringing it to you in the Azure Stack. Networking is another perfect example. We make over 50,000 changes a day on the Azure network. A day, not a week, not a month, not a year, a single day. Any one of those changes could have catastrophic effects. So what have we learned? Well, we've learned that software-defined networking is exactly how you do this. There's no humans involved. There's no humans actually fat-fingering typing changes into switches and firewalls and changing ACLs. And that's craziness. That's absolutely craziness. That's why software-defined networking is there. And that's why we're bringing even more networking to bear with network function virtualization. I mentioned this yesterday in the keynote. It's why we're bringing the software-based load balancer, the distributed firewall, the network controller, all of these cool capabilities that have been running in Azure that you've been able to use, but you've actually never been able to run on your premises. Guess what? We're packaging them up and giving them to you as part of Azure Stack. And the thing that I love most is this has already been tested and hardened over years of use. If you watched the Sochi Olympics last year, we delivered to over 100 million customers on 4 continents. If you watched any of the Sochi Olympics on your PC, your phone, your Mac, your Android, your Slate, your whatever it was coming through Azure, and it was going through those software-based load balancers. So guess what? It's already been tested at planetary scale, and we're going to give those to you. So that's a huge win for you, and it's a huge win for us because we're driving that consistency. So as we look ahead now, Azure was the design point in 2012 R2, but as we move ahead to 2016 wave, it's about cloud-first innovation. It's about the infrastructure and about that application platform. What do we mean by that? It means exactly this. We've been running Microsoft Azure with our cloud infrastructure, Portal, IaaS, PaaS services, and quite simply, what do you want to run? Windows Server, Linux? We don't care. Go into Azure. Go take a look at the gallery. Debian's there, Ubuntu's there, CentOS is there, SLES is there. You want to run Oracle Linux, you want to run Oracle Unbreakable Linux, you want to run Oracle Java, you want to run Oracle, it's all there. And we're continuing to add more. Well, guess what? Now we're saying we're packaging it up, we're putting Azure Stack for you so that you can take advantage of those services on your premises. And so when you write that single application now, that cloud app, it runs in Azure or it runs in Azure Stack. Everybody's happy. You want to deliver IaaS services, you want to deliver PaaS services, great. You want exactly the same set of APIs for northbound and southbound APIs for networking, it's all there. Think about just what that means to now your agility to get things done. It's pretty amazing. So, what's on your mind today? Well, a lot of questions we hear. How can I better deliver on my mission-critical app needs? How can I protect my data center assets from emerging threats? And let's be clear, that one has really risen up a lot. The bad guys are getting a lot better at what they do. We've got to stay ahead of them. If we still think it's, 2001, 2003, it's the XP days, it's Windows Server 2003 days, and you think that's fine, you're not living in reality. The bad guys have gotten a lot worse. Guess what? We understand that. We've been working on this constantly to harden our systems and deliver new capabilities, and we're excited to talk about some new ones you probably haven't heard of yet coming in 2016. How can I empower next generation app services for my app owners? Yes. So let's get into this. About deploying enterprise-grade virtualization and our IaaS platform. One of the interesting things is over the years in Server, we've delivered Windows Server on a pretty regular cadence. It's been about every 2 to 3 years, pretty much like clockwork. And I would hear every so often someone say, Jeff, you're too slow. That's just too slow. 2 to 3 years? No, I can't wait that long. Everyone's moving a lot faster. Microsoft, you're way behind. So we said, okay, fine. I hear you loud and clear. 2012, we released. A year later, just slightly under a year later, we released 2012 R2. You know what the biggest complaint was? Everyone came screaming back, "That's too fast." What are you talking about? You've been like tearing my ear off telling me we're too slow, and now we do it in a year, and now we're way too fast, and we're too disruptive. What are you doing, Microsoft? We just got finished deploying 2012, and now's R2. But when we actually like peeled the onion back and looked into this further, what we found out was this. You actually really want the fast innovation. People looked at 2012 and said, "Oh my gosh, this is really sweet. I'm going to start deploying this now." R2 came out, and people went, "Oh my gosh, there's hundreds of new features in here too, and these are all really sweet, and I want these right now." But the problem is, I want to be able to take that infrastructure very quickly, but I don't want to change any of my workloads on top. That's what we really found out. It's like, we want that infrastructure, please, give us more features. Oh yeah, storage tiering, automatic storage tiering on R2, yes please. Storage pinning, oh yes please, I'll take more of that please. Oh my gosh, you've got shared VHDX in 2012 R2, oh my gosh, yes I want that, but my apps on top, oh, they just need to keep running. So one of the things we knew we needed to fix was we need to be able to make that change a lot faster. You basically said, we want a quick time to value, we expect and require enterprise-grade reliability and heterogeneous flexibility. So how we were doing that? Through frictionless cloud cadence infrastructure upgrades, through benchmark setting scale, performance, resilience, and to continue the work that we started many, many years ago, making sure that Linux just rocks on Hyper-V. Go download any modern version of Linux, just install it on Hyper-V. Guess what? It just works. All the drivers are there. We've been contributing the drivers to the Linux kernel for ages. My team actually started that 7 years ago. I kind of lost track. It's been so long. People were shocked to find out we were doing it. Just works. You don't need to download any special tools. It's already built right there. It's in the mainline kernel. We've been doing all that work in the open source community in the open now for many, many years. So what does a frictionless cloud cadence infrastructure upgrade mean? It means rolling upgrades. It means you can have a cluster in place and upgrade it to the next release. We started some of this work in 2012 R2, where you could basically live migrate from 2012 to 2012 R2, called cross-version live migration, but it meant you had to have a second set of servers. This one we're actually saying now, you can have a single cluster we can upgrade in place, and we'll walk through that in a minute. We continue to work very closely with all of our partners in SQL Exchange, SharePoint, SAP, Oracle, and you talk to them, they're basically going to tell you the same thing. I don't care what anybody other vendor says about their virtualization benchmarks. Okay? They're all irrelevant, and I'll tell you why. Because they won't let me perform my own benchmarks. Okay? It's really simple. VMware's had a clause in their EULA forever that says, I can't perform a benchmark against VMware without their express written consent. That's what you do when you're afraid. Okay? It's real simple. Go talk to the SQL team. Go talk to the SharePoint team. Go talk to Exchange. Go talk to SAP. Go talk to Oracle. They're going to tell you the same thing. The best way to run this virtualized is on Hyper-V, bar none, period. End of story. And we continue to tune, we continue to tweak, we continue to make it better in every release. It's that simple. In terms of Linux support, that's been ongoing. And the nice thing about the Linux support, by the way, I should point out, is that actually doesn't track to a Windows release. That work is ongoing constantly. That's on its own release cadence, and we work very closely with the open source community. So we've actually added features into Linux over time that have just appeared. For example, hot adding, removing vNICs, and in-guest VRSS. Actually, I take that back. Hot add, remove vNIC is coming in 2016, but in-guest VRSS is something that can come sooner. So we're able to do things that allow us to actually innovate on Linux on its own cadence and do things even faster. So in terms of the cluster OS rolling upgrade, this is something, this has been a tight partnership with Matthew's team and the storage team and the scale-out file server and what we've been doing and the failover clustering team. And very quickly to just kind of walk through this, because I want to get to some of the really cool demos we have here for some other technologies here. But the way the cluster OS rolling upgrade works is this, because we've mentioned this a couple times. I've had a bunch of people ask me, Jeff, how does this work? And here's exactly how it works. If you've got a Windows Server 2012 R2 cluster, just like this, here's a 5-node cluster, and it's running at a cluster functional level of 2012 R2. I want to upgrade this to 2016. How do I do that? Well, the first thing you're going to do is you're going to drain one of the nodes, all the VMs off. So I've drained node number 5, and then I'm going to evict that node from the cluster. While it's evicted, I'm going to go ahead, I'm going to install the new OS, and I'm going to configure it. Now, I'm going to bring it back into the cluster. And now, even though it's running Windows Server 2016, it's actually running at the functional level of 2012 R2. So this is technically a mixed mode cluster because I've got Windows Server 2012 R2 hosts and Server 2016 running together. I then will walk through, I will migrate those workloads back, so I will move those VMs back, so now it's hosting VMs. And I'm literally going to walk through every node in the cluster, upgrading them one by one. And by the way, in case you're wondering, yes, this is fully automated. You can do this through PowerShell, or you can do this through VMM, and you can kick back and watch the whole thing happen. Pretty sweet. Once you finally get through the whole process, and you've actually, now all my servers are up to 2016, if you want, you can keep running 2012 R2. I've had a couple people say, hey, do I have to do this immediately? Can I just sit back and watch it for a couple days? Absolutely, sure. But once you're fine with it and you feel confident, guess what? Now you're just going to upgrade the cluster functional level from 2012 R2 to 2016. That's a simple one-line PowerShell. Once you've done that, now you can take advantages of the new features of a 2016 level cluster. That's it. And just like that, your upgrade is completed. This is true if you're running Hyper-V, and it's also true if you're running the scale-out file server. So it means now for our software-defined compute and our software-defined storage, you can upgrade them in place without any downtime to the workloads. Because the VMs running on top of Hyper-V or the storage running on top of the storage server continue to run without any downtime. There's no loss. Your customers won't see anything. Your tenants that are using their VMs or the folks accessing storage won't see it. Zero downtime infrastructure upgrade. And that's how it works. So, optimizing workload availability and performance. I want to hand this on over to Matthew. I've been talking far too long. Matthew, tell us about some of the work that's been happening in Hyper-V around availability and performance.
Sure. Can you hear me? Yes. So specifically around workload optimization, what we have really done is introduce a bunch of capabilities to the storage stack. One of the design points that Jeff was talking about is around the notion of building cloud-like architectures. Part of the implication of that statement implies that we are taking advantage of commodity hardware. Now, virtualization, the way we used to build the virtualization stack in the past used to be that we assume a highly resilient hardware environment where you had SANs with 5 or 6 nines of resiliency, a specific network that was always available. So the model that we used was fail fast. So if there's any disruption in your storage stack, the first thing you want to do is just shut the VM down, migrate it, fail over to another node, and start it up as quickly as possible. But as we discover in this new world, we don't want to spend all that money on high-end SAN infrastructure. So what we end up doing is bring the smarts into the software stack, into the virtualization stack, and the way we do that is by allowing for some level of resiliency. And there are two kinds of resiliency we are talking about here. There's the whole cluster level resiliency where a node is considered not part of the environment if it loses connectivity with the rest of the system. So in the past, we would just kill all the VMs and then migrate it as quickly as possible. But in 2016, what we have is a mode which allows the VMs to keep running for a couple of minutes to ensure that maybe the system can come back up. And so if that's the case, then you never lost any of your workloads or incurred any of the downtime. A very similar situation is with the storage part as well. If the VM loses connectivity with the storage, the regular model is that the VM will either bug check or we have to cause a failover to happen. Now we pause the VMs, and folks who are familiar with VMware might say, hey, VMware has always done that. They're right. As we discover that this is a new architecture, we believe that's the right model, so we adopt it. No qualms about following what is the right practice here. The other thing, which is fairly interesting and unique for us, was also the storage QoS, or quality of service capabilities that we introduced. Now, in 2012 R2, we started with storage quality of service, where the first step was, can I give limits to the way I'm taking advantage of storage? So there are two parts to any quality of service statement. There's the reservation part, and then there is the limits part. So in 2012 R2, we were able to do both, but the reservation was for a single machine. So how reservation works is really if you reserve a certain number of IOPS for a given VM, the only way to guarantee that the VM gets that is actually by throttling all the other workloads. Now that's great if your storage is on a single host, and so we could throttle the other VMs on one host. So in 2016, we took it, we expanded the scope of that, and we said all storage, all hosts connected to a single shared storage should have the same benefit. So across a cluster, across shared storage, we are able to bring the storage cost capability where we say that VMs on that shared storage infrastructure, you can reserve specific IOPS, and we work with the storage backend to make sure that the specific IOPS are met for that particular VM. And if for some reason there are other VMs that are even on different nodes, if they start consuming more IOPS, we have the mechanism to throttle those IOPS right at the Hyper-V end or at the storage end. So with that.
So one of the things real quickly about storage quads, very interesting to point out, was in 2012 R2, we were really laying the groundwork for what we're doing in 2016. In 2012 R2, again, it's fantastic for a single host. But now what we're delivering is a cluster-wide storage quad. And think about what the problem is we're really solving here. This is honest to goodness, really storage quads. We've been asked for this for a while. We've had quads for memory and CPU and networking for some time, but this is the last one, and this is a big one. Because this is the case where you've got 10 VMs on a single host or 10 VMs in a cluster, and they're all running fine, but then somebody fires up VM number 11, which happens to be SQL, and it's trying to consume every last bit of IOP out of storage, and they may be happy, but the other tenants are not. Now, with the mindset of, hey, you know what, I'm going to run IT as a service. Okay, I can now provide to a service level of agreement. The way to do that is through quality of service. And maybe my SQL guys, they're going to pay for platinum storage, and but they're still going to get a maximum amount of IOPS without starving the rest. And even though the other folks may have bronze, silver, or some other type of storage, they're going to still meet their requirements as well. Again, making you guys the heroes. Everybody's happy, but they're also getting what they pay for. And that's a big part of what storage quads is all about in 2016. Next, we've got Azure IaaS scale-up options. So Madan, why don't you tell us a little bit about this?
So for some reason the pictures are not showing, but we've been fortunate to kind of bear the fruits of all the innovation in Hyper-V and the OS team. So we've been able to offer kind of the full spectrum of scale offerings, right? Whether it is your scale for your budget, which is the series of machines. I'll quickly show a demo here.
Yeah.
We support a variety of virtual machine sizes here. So this is our A series. If you go below, so this is our basic A series, and this is really meant for dev and test, right? So at a fraction of cost, you're able to kind of get variety of options in terms of scale, all the way from a single core to 8 cores, 14 gigs. We have what we call as a standard tier, where you have better, quality of services in terms of performance isolation. Again, the same VM sizes plus something more. We have the high memory and the high compute sizes with A8, A9, A11. And then we also have the new D series, which we announced, which have local SSD space for applications that can take advantage of the local SSD space, like SQL Server as a buffer pool extension technology that can allow, fast storage locally. And last but not the least, we also have two other types of virtual machine sizes. One is called DS series. This is our premium storage offering. We have standard storage and premium storage. Premium storage has higher IOPS and lower latencies for especially database patterns. And then we have the G series, which is kind of the biggest virtual machine in the market in any public cloud provider. So I'll quickly show you an example.
Wait a minute, how many cores is that?
Yeah, that's a good point. 32 cores, 448 gigs of RAM, 6 terabytes of SSD locally, right? And you can attach 64 terabytes of disk space. So
that'd be a great Quake server.
Right, literally, the biggest, baddest workloads can run on Azure, right? So I'll quickly show you what this looks like. So here, basically, I have an IO meter running on a standard storage. Today our standard storage per disk is essentially capable of delivering around 500 IOPS, which is what you're seeing. I'm just running a database pattern, an 8K pattern. And then if I go and change it to, let me change it to a premium storage. And then I run the test again. And you can see I get up to 5,000 IOPS. This is basically single premium storage disk.
I'll take 10x performance boost, please. Thank you.
Yes, and I have a machine, which basically has 20 disks attached. And if I run the same workload, it's basically an 8K database workload. You basically get over 60,000 IOPS. And then if you want to
use
press more,
60,000 IOPS in a VM in the cloud? Anybody? Anybody can use that? Yeah.
all right. And if you want to go even further, this is our G series.
All right.
And,
Whoa! Do not adjust your set.
I can go even further. So literally, we have the scale options there. And so if I want to run a real SQL Server workload, so this is SQL Server 2014. I'm running the AdventureWorks database. So what I've done is I've basically created a database running on premium storage. And on the same VM, I have standard storage as well. It's running a hackathon workload. Basically, what I'm doing is I'm inserting 20 sales orders inside the AdventureWorks databases. And I'm basically running 10 concurrent threads and 500 iterations. So basically 100,000 sales order inserts, right? It's all in memory using our in-memory technology. So I'm going to fire off both, and I want you to kind of take a look at this column here, the log-based flush. So you can see the log activity here. We have literally like 10 times more. And then if you also look at kind of the transactions, about transactions per second is around 5 to 6 times, right? And you'll quickly see the workload that's running premium would finish in literally like 1/5 of the time, compared to the standard storage. So real workload delivering, real value to customers. So and all the good work from Hyper-V team and the host team essentially is, helping us here. So if you could go back to number 5.
Yeah.
I think it's your next.
Awesome, Anand. Thank you.
Thank you.
What you just saw there is a perfect example of the work that started here. Okay, in 2012, we demonstrated for the first time VMs running with over 1 million IOPS out of a single VM. A year later, at 2012 R2, I demonstrated at TechEd Europe, a single VM delivering over 1,600,000 IOPS. And last year at TechEd, when we did our first tech preview for the Windows Server 2016, I demonstrated over 2.1 million IOPS out of a single VM. These are crazy numbers. Well, what this means is every time we continue to optimize and refine even further the storage stack, these guys take those bits, and guess what? It means we can deliver this type of storage, this type of performance to you in Azure, and everybody benefits. So truly awesome work going on there. SQL guys love this. Just totally love this. So next, how can I protect my data center assets from emerging threats? Wow, okay, if this isn't at the top of everyone's mind, I really don't know what is. We've had some really hard, we've had some really big news over the last years. We've had some massive threats that have been coming up, and everybody's reporting it everywhere from the New York Times to Ars Technica. The motivations are getting bigger and bigger. The bad guys are getting a lot better at what they do and doing it from other countries, quite honestly, so they're not as worried about being caught. How hackers allegedly stole unlimited amounts of cash from a bank in just a few hours. The biggest cyber threat to companies could come from inside. And malware burrows deep inside computer BIOS to escape AV. BIOS. That's not the OS. Bad guys have said, look, it's harder and harder and harder to break the OS. We're going after easier targets. We're going after apps that are running, or if we can bury ourselves into firmwares and BIOS, that gives us another way to attack the system. So, with this move to the cloud, Matthew, we're doing lots of interesting things to harden VMs, to make VMs more secure, but there's still nothing we can do against an admin, right?
You are absolutely right. Can you hear me? Yes. So, Jeff, thank you very much for that intro. I think what you're really alluding to is, on one hand, we are saying the world is moving to the cloud.
Yes.
People are moving to the cloud. And then on the other hand, you are raising these concerns saying, it's darn difficult to protect what I have on-prem. And now you want me to move my sensitive workloads, my data to the cloud, where I have to trust not just the hoster environment, but I have to trust the administrators over there. Right.
It's one thing for me to trust my own IT. Okay, maybe I'm in a small enough organization, maybe I'm in a startup and there's 100 people, and I actually kind of know everybody in the company. It's another thing to be in a company that's got thousands of employees and we've got some IT. I sort of trust my IT. I don't know any of these people. I don't know any of these admins. I don't know what our hiring practices are, but I assume I trust my own IT. They're doing their best for the greater good of the company. Okay, so I more or less do, but what happens when an admin has a bad day? Okay, he gets a bad performance review. He's going to leave the company. How do I know he's not taking some of the company's secrets with me? Or here's a different thought. Okay, it's one thing to say, you know what? This is my phone. I'm holding my phone. I trust my phone. My phone is actually encrypted. But if I'm going to move to the cloud, I'm going to give my phone to Matthew. And I'm going to tell Matthew, Matthew, you're going to run my phone. You're going to provide me phone as a service, right? How do I trust Matthew? And in fact, maybe I trust the company Matthew works for, but I don't actually know Matthew personally. And I don't know, is he trying to crack into my phone? I mean, I did put encryption on there, right? So I should be safe, right? So how do we solve some of these problems? I mean, if I give this to him, can't he attach a debugger? Can't he create a crash dump? Can't you look inside my phone?
I have a solution.
What's your solution?
I can give you a virtual TPM for your VM, so you can BitLocker your VM.
Okay, so if you give me a virtual TPM, and it's in my VM, but you're the admin. And if you're the admin, you can inspect memory. And those BitLocker keys, where are those BitLocker keys stored?
Yeah, it's on the host.
So hold on. You give me a TPM, but the file is encrypted and memory can be seen by you. So
Yes.
how did this help me?
Yes. So thank you very much.
Yeah.
That's exactly the problem that's facing the virtualization industry. The fact that the administrator on any physical box is God. He can or she can do anything they want. They can access memory. They can look at installed bits. You can have group policies that prevent it, but you can work around those if you're the physical local admin on the box.
And that's true on any platform. Windows, Linux, Mac OS, VMware. I don't care what platform you're talking about. If you're admin, period, end of story. You can do anything.
And
How do we solve this?
Right. So when we thought about the problem, I said this is going to be a problem. This was a couple of years back when we started looking at this and say, if we have to go to the cloud, if we have to get folks to the cloud, we really need to break that pattern. We need to break the pattern which says administrator is the God. And so for that reason, what we had was we had to create an environment which was inaccessible even to the administrator. So we came up with an interesting technology. We named it Virtual Secure Mode, not the best name possible. It was a bunch of engineers trying to figure out what to do with this. But the key and the core of that technology was Microsoft and Windows, we wanted to create an environment in which no one, literally no one, can access what's going on inside, whether it's data or code. We have a very secure, very small environment and keep it completely pristine and away from the administrator.
But hold it, Matthew, can't you peek into this VSM Virtual Secure Mode? Can't you peek in there?
Nope. We have made sure that using the same virtualization technologies, created a small environment that's memory segregated or partitioned from the main OS, such that what's running in there or the data in there is completely opaque and hidden from the kernel, even from the kernel of the main operating system.
Even from the kernel?
Yes.
So you can't dump memory and see what's running in VSM?
Correct. So if you do a crash dump of the physical host, that particular section will be encrypted. It won't be visible to anyone. You attach a debugger, it won't allow you to do it.
So now you're saying with TPM and BitLocker and VSM?
Yes. So now, once we have this environment, we can do few magical things with it. Essentially build all these promises. So when you have a virtual TPM inside the virtual machine, the virtual TPM on the physical host will be accessible to the administrator in the normal world. But what we did was we encrypted the virtual TPM, and the decryption of that virtual TPM will only happen inside this virtual secure mode. We prevent the virtual machine from being accessed by the administrator. The administrator will not be able to dump that virtual machine's memory either. We prevent access to that part, so you can't peek into the memory. In fact, we went a step further saying, well, you can't do memory peeking. What about live migration traffic? Can't I sniff that packets and extract all the memory information? Nope, we are encrypting that. And guess where the encryption is happening? Again, backed by the VSM. Well, you know, Mark Rusinovich has written an awesome tool with sysinternals, and there are surely other things.
Yes.
Can't I just install it on that host and get to it? Well, that's where we have something called code integrity, where with VSM, we are ensuring that only signed binaries can run on it. The hoster environment, the hoster decides, the hosting company decides what binaries are allowed to run on that Hyper-V host. If sysinternals, for whatever reason, is one of those approved things, sure, the admin can do it, but then you probably should not be hosting in the company which allows sysinternals as a tool to run on the host. So essentially, we are allowing the environment to be as locked down as possible, so the administrator, even though he or she is God, cannot do those God-like things, including installing applications that are not safe to run in that environment. So yes, so we prevent that. You cannot attach a debugger to that virtual machine, so you can't connect to it and get into it. What else did I miss? VM console, VM Connect. So if you can just wait for VM Connect to happen, so somebody else logged into the VM and then you just wait for it and say, aha, I think someone has connected, let me steal that VM Connect session and connect to it. Well, guess what? We are going to lock that. So the minute you switch over VM Connect, we are going to lock that. So essentially what we are doing is we are going step by step through each and every access point and ensuring that the administrator on the box cannot have access to that particular virtual machine. And that virtual machine, really, we call it a shielded VM. But that's not the full story. So there's more to it.
Wow. So think about what you heard for just a second here. I want to replay something here. We've always had isolation between guests, but we've always said that you have to trust the host. What we're now saying is, folks, you can actually use encryption, you can run your virtual machines, but now you are actually protected against the host admin. We're using hardware-rooted technologies to separate the guest systems from the host administrators. And this is truly by removing this from the context of the kernel itself, as well as the host admin using virtual secure mode.
But here's the cool thing, right? So you can still dig down the rabbit hole.
Yes.
You can say, you know what? I have a data center. I am the administrator. Sure, there are machines there. I can bring my laptop. It has VSM. I'll connect it to the network. And I'll say, you know what? Let's live migrate those VMs over. But this special laptop, I have some hardware magical things in there with which I can snoop in. So, aha, I get that.
Yes. Let's move this to a host that we can manipulate.
Right. So we said, you know, sure, that's possible. Let's prevent that as well. And that's where we have our Guardian service, a fabric that's ensured to be guarded against. And so the way we decided to go about doing that was you have to start right from the purchasing decision that you're making. Day one, you have decided that you need about 100 machines that you're going to buy from your favorite OEM. You give the order, the OEM gives you a manifest of information saying these are the machines you're going to get. So you're guaranteed what the machines are, the firmware, so we can prevent against those BIOS attacks. We want to make sure that right from day one, right from the inception, we know and trust the environment. How do you guarantee that the machines you ordered are really the ones that you got? What if some malicious people along the way swapped some of those machines and replaced with another one? And that's where it's very important to understand how do we uniquely identify each of those machines. And the only way today to uniquely identify a machine is using a physical TPM. So if there's a physical TPM on the hardware machine, in my manifest I can specify these are the machines with these TPM signatures that I'm going to get. At that point, when I get that in my data center, I can correlate and make sure that all 100 match what I had explicitly ordered. Whatever the OEM had shipped is the ones that I got. I ingest it into my data center. My Guardian service is now aware of these 100 machines and nothing else. And so when these machines boot up, they have to say, this is who I am based on the TPM on that machine. This is the health of my system based on the patch level and operating system running on it, which was provided to it by the data center. And now, Guardian Service, can you please release the keys to unlock the shielded VM that I want to run on my machine? So now we come back to that BitLock, the malicious administrator scenario who has the laptop, who says, let me bring my laptop to the data center. I plug it in. Sure, you can plug it in. I can copy the VM. Sure, you can copy the VM. I want to start the VM. Because at start time, it will go and says, hey, Guardian Service, I need a key to unlock this VM. And the Guardian says, who are you? I am this random laptop. Sorry, you don't have access. Now, you can run any other VM which is not shielded, but you cannot unlock and run the VM that has been deemed shielded. This is one of the most powerful statements that a hoster can make to their tenant. And the hoster can be your internal IT department. Like, you can make that promise to your workload owner saying, you know, with this, please don't blame me if there's leakage. Sure, you might have leaks in your environment, departmental guys, but the leak will not originate from me if you do the right things, because I can't. The most I can do is I can sell the VHD, but the VHD is completely encrypted. So I can't do anything. Oh, there's a question.
So what if I want to take a VHD, it's got a virtual machine that's running on it, and move it to a different host, to bring it in, take a case like I copied that, bring it over to a different host, in a test environment, try and upgrade ahead of time. Will it be able to start?
So the question was, if I have a shielded VM that's already encrypted, and I move it to another host?
Yeah, to run it in a test environment to try and upgrade. So you take a snapshot of that VHD, and now you move it over to a to a different host, and you fire it up. You're going to try running an app upgrade or something.
Sure.
You're allowed to start.
So the question is, can I move my virtual machines from one host to another host to perform maintenance operation inside the virtual machine? And the answer is, if the host environment, the new host environment is part of the trusted environment, absolutely. If it is not, then no. Because that's a very explicit.
Yeah. No, you're talking about going from like a staging to production, or pulling out a copy to just test a patch before you roll it back into production. Very common. Yeah, you would make sure that the host is part of the Guardian service. It's part of the trusted host to do that. Otherwise, no, it's not going to run it if you take it out.
Because the scenario is no different than if we don't know whether you're trying to do it maliciously or not.
Exactly. We don't know your motivation behind doing it. Are you taking a snapshot so that you can go try and crack things and steal credit card numbers? Or is it really truly a test dev patching
The
operation?
flip side is, if you have the BitLocker key or the recovery key for what's inside the virtual machine, you can take it and you can do the recovery thing. So whatever we are building is not a solution that will solve all security problems. It's raising the bar significantly such that now you're giving your tenant more options. Now, even with the virtual TPM inside the VM, the tenant might choose not to turn on BitLocker, in which case there is no security. We can protect everything you want, but the VHD is unencrypted because they have opted not to turn on BitLocker. Or they might turn off BitLocker for maintenance activities, but that's a very explicit.
But now it's in the control of the tenant, which is really what people are asking for. Is, look, I just want to make sure that I can control the level of security which I'm doing it. If this is just a random system I'm using for test dev, or this is the QA box, I don't care about this. Fine, I don't need BitLocker. I don't need to do any of that encryption. But this is a production workload that houses company secrets or credit cards or that type of data, HIPAA data, Sarbanes-Oxley type of data, PCI compliant data. That stuff I absolutely want to put into Shield VM, and I never want this thing running on a system that's not a part of the Guardian service.
So again, just reiterating, of all the things that we are doing, this is probably one of those most innovative things that we have started grounds up that enable level of assurance and trust that's unprecedented in cloud or virtualization worlds. Sorry, you have a question?
Keys and keys management.
Yes.
Doing something special for that also to make it easy for some time?
Absolutely. Now, I probably won't go into depth. There are 2 more sessions. So there's one later on.
Yeah, we still have to get the containers, guys.
Yes. right? So please do attend that. This is very near and dear to me. So there are a couple of sessions where you can go deeper into how to set up the environment. All I wanted to convey was the value prop of what we are building. Wanted to impress upon you that cloud is awesome and it's great and we are doing all the things, but we are also ensuring that it's safe for you to migrate and go and make it happen with confidence.
And one thing, I'll be honest with you, the feedback we've already heard very early on, talking with all sorts of different types of verticals, healthcare, government, financial, military, they basically said, oh my gosh, this is like truly what we've been waiting for. From a hardware perspective, just so you know, this will require a hardware TPM 2.0 in the server. I realized we didn't put that on the slide, so I had to make sure to call that out. TPMs are not very common in servers today. They're very common in laptops and tablets. So this is something we are very much driving in the hardware industry. And if you wouldn't mind letting your hardware OEM know that you think this is valuable and you'd like to see a TPM 2.0 in the server so you could take advantage of it, I think they'd appreciate that feedback. But we've been letting them know about this for a while because it will require that to give you the shielded VM promise. And it has to be TPM 2.0, right, not TPM 1. anything. It's got to be 2.0.
Let me temper that a bit.
Yes.
So TPM 2.0 is required for the full promise that I described, but you can deploy the solution even without the TPM solution. It's that the level of promise that you can do, and that's the example I was giving. If you trust your environment and your deployment such that an administrator cannot bring their laptop and connect it, then you are okay to relax that TPM requirement. Though going forward, so this is to ensure that your existing hardware can take advantage of these technologies, but going forward, having the TPM increases the level of security and isolation that you can have and the guarantee that you can make for yourself and for your tenants. Can I not take the question and wait for the end? Sorry.
Yeah, we'll be happy to take questions afterwards.
Some more interesting things that we need to talk about.
Yes.
So very quickly, if I go through these slides, I really don't want to go through the slides because this is the essence of what we talked about. Yes. The remaining 2 sessions we have will cover all these things in depth, and I implore you, if this is an area of interest, please do attend those. So let's switch over and keep moving to what's next. We keep talking about servers. Well, actually, you know, Madan needs to drive this session as well.
All right, so the third chapter is really about kind of the next generation application. So in Azure, as with any cloud provider, we are accelerating the pace of innovation. And what that means for developers is there is a new kind of application that is built, which is globally distributed, and that's a native design point, right? It's based on services as opposed to servers, as Jeff pointed out, and the primary, from an Azure point of view, both Azure Stack as well as Azure, the primary value proposition here is, we are providing a spectrum of options, right? Right from your virtual machine options, we saw the different sizes that we demonstrated in public cloud and obviously in on-premises where, you get to pick your size. We also have containers. Matthew is going to spend a bit more time in terms of the innovation that's happening here, which is essentially becoming the substrate of, a lot of the microservices. And then Azure Service Fabric, which is a compute service that we announced last week at Build. And it's basically, think of it as the orchestration and automation tool for developers and IT admins that are building stateful and stateless microservices, right? The key difference here is, you have, incredible app awareness and insight with this particular orchestration tool. And all this offerings along the spectrum is something that will be consistent. We have our consistency promise that Jeff talked about, regardless of whether you're running on Azure Stack in your own on-premises hardware or on a service provider or on Microsoft Azure, you write your application once, you deploy your application once, and you have the promise of being able to deploy anywhere, right? So literally an Azure that can essentially be hosted anywhere, whether it's managed by us or, by a service provider or by yourself. And a true demonstration of this promise is what we announced last week again, called Azure Resource Manager Support for Infrastructure as a Service. I'll keep it at a very high level. Azure Resource Manager is the new control plane that will essentially span Azure Stack, public Azure, and hybrid, in between them, right? So this is your service management plane where you deploy all resources that are under the umbrella of Azure. And the idea behind this is you're creating JSON templates which are essentially, infrastructure as a code, right? So this is your unification of responsibilities between, developers and the IT administrators, where you have a clear contract, right? Developers want to deploy, say, for example, like, 100 virtual machines, running, I don't know, a SharePoint form, a MongoDB cluster, pick whatever application that you want. You end up producing a template that essentially becomes the contract between the developer and the IT administrator to say, look, this is what I want to deploy, regardless of the environment that I want to host my application, whether it's Azure Stack, whether it's public Azure, whatever particular region that you want to deploy, of all the 22 regions that you have, or all the service providers that will start supporting Azure Stack, right? So you don't have to change a single thing. If I was a developer, I don't have to change my application. If I was an IT administrator, I get the promise of standardization, right? The template essentially becomes the code. It becomes a source file that you can check in and that you can revision upon, over and over. And the Azure control plane, whether it's running on Azure Stack or public Azure, can take this template, which is essentially the infrastructure as a code, and then execute it. You can execute things in parallel. You can create 100 virtual machines in parallel, or you can create complex dependencies like SharePoint form. You have to have the Active Directory come up first, and then the database, and then the front end. You can do all those complex modeling of your deployment, and then automate it, right? So this gives extreme, agility both for developers as well as IT administrators, and it spans the entire spectrum of services. Virtual machines, networks, load balancers, all the way down to the nuts and bolts of your application, right? Public IP addresses, the VNets that you want to configure, and so on and so forth. And what we've done today is, if I want to quickly show this, 7. We've created a community of templates for you to kind of get started. I'm not going to spend a whole lot of time here, but really quickly, I wanted to show this web page. If you want to get started today, especially how it will look like in Azure Stack. So if you go under azure.com community and then templates, we have a lot of starter templates that you can actually get started today. These are open source. It's all in GitHub. You can see, commands right there. And this will be the same exact commands that you will need to deploy an Azure Stack when we make the bits available. So the promise of consistency remains. Jeff, if you can get number 5. And then talk about containers. It's again, the same spirit of consistency that is fueling the appeal for containers. So what is containers? It basically, if you approach it from a developer and an IT administrator point of view, this is this phenomenon of DevOps where developers want rapid agility. They are appealed by the fact that I have production realism. I package my container, within this small isolated execution environment, and then I can throw it anywhere, any hosting environment. Azure Stack could be one, public Azure could be one, or any public cloud provider, or any physical service provider. And I get this production realism. What I ran within the container would look exactly the same. And this is not just a single container application. It could be a multi-tier, multi-container application, right? And what we are saying, with containers is this: we want to see the developers increase their agility and productivity as app owners, but we also make sure that IT administrators have the flexibility and the control in order to be able to govern this, this rapid innovation. Because if it's a two-way street. If you have agility from a developer point of view, but no governance, you haven't gained anything, and vice versa, right? So we have been doing a bunch of work around. If I can go back. Get the slide moving.
Back or front?
Yeah, this one. So we've been doing a lot of work with Docker. Docker is kind of the de facto standard for managing containers today. And Docker is really 3 things. It's basically an open source runtime that allows you to manage Linux containers today, and really soon Windows Server containers. It is also a packaging format for basically if you're creating an application that runs within the isolated container environment, you can actually package it. And the third thing, which is you can store it in a public repository or a private repository called Docker Hub. And we've been deepening our partnership since October last year. And some of the strategic investments that we made is we've committed to kind of creating an open source Docker engine that can manage Windows Server containers. Matthew is going to demonstrate that. And we also, from Azure point of view, we already have excellent support for Docker integrated right into the platform. So in order for you to get started, it just takes a few minutes for you to kind of spin up a virtual machine with Docker already enabled. And we also now moving into integrating with their open orchestration APIs. So if you are creating like tens and thousands of containers, they have an orchestration layer that can actually manage all these containers, stateful or stateless. And Azure has first-class integration for it. And pretty soon you will see this content show up in our Azure marketplace as well. So without further ado, I want Matthew to demonstrate, the Windows Server containers in action.
All right. So very quickly, you heard a bunch of things. You heard the term container. At our booth, a bunch of people kept asking us, what is a container? How do you correlate with known terms that you're already aware of? A very crude way to associate what a container is by thinking of it like a VM, but please never say it's a VM because it's different. The difference is in the way you approach it. The difference is in the way you deploy it. It's a developer tool that spreads itself into an operations model that lends itself very well to the next generation of applications. When Jeff talked about stop thinking about servers, start thinking about services, containers becomes an underlying technology with which you start enabling those things. So when you're writing the next generation of applications, when your developers writing it, they'll probably be thinking of, I'm going to think containers. And as IT administrators and IT pros, you are going to think about containers as the mechanism with which you are deploying applications. But from a runtime perspective, each container essentially gives a view to their workload as if it's a VM of its own. It's complete environment. It's from inside the container, it feels like that environment is built specifically for that workload, which is kind of somewhat of a definition of the virtual machine.
Another way to think of it, I found, let me just throw these words out there because I find this works. OS virtualization. Think about that for a second. Imagine you're on your system and you brought up another window that looks just like that system you're on, except at its own environment. A container is really OS virtualization. Has its own view of the file system, has its own view of the registry, it's isolated from a process standpoint, but it looks just like that same OS. It doesn't look like a virtual machine.
So there is another session, again, to go much detailed into this. Please attend that. Here I'm going to give you a quick demo. And so in my demo setup, what I have is a virtual machine set up running Windows Server Core 2016 that's acting as a container host. This PowerShell window is actually running on my client box. It's running a Docker client on PowerShell. And so let me take a pause again and talk a bit more about Docker. Docker is an open source project. They are the ones who connected the dots with containers, with images, and with the Docker Hub, and they introduced containers as the modern environment, as a modern runtime environment. This is also a new Microsoft where we are embracing open source as heavily as you can see it, ensuring that we provide the best of the breed solution to your customers, to our customers as well. So here what I have is a VM. This is the VM that's running. It's running the Docker daemon in there, and that's where the containers are going to get created inside this VM. These two PowerShell sessions are outside, and I'm just executing a bunch of commands. So the first command that you see here that I've already executed was the Docker build command, where I'm just creating another image called a demo. And inside that demo image, I have a very simple ASP.NET application. In fact, in this particular case, it's a standard template. If you use Visual Studio, if you just press F5 once you create it, this is what gets created. I just created an image off of that, and I'm just going to run that. If I can. There you go. And so that's all it takes to start up a container. On this other window, what I'm showing is you can look at what the images are there. I see two images right there. I can check which containers are running there. I can see there's already one container up. And essentially what you're seeing here is I'm launching containers. And that run command is what is launching. And you can notice in this case, the output said it started the service and it's listening on that particular port. I need to get the IP address of that. So the way I'm going to do that is simply support Docker exec command, which means I want to run a command inside the Docker container. And I'm saying I want to get the IP address of that. And I'm just going to ignore that demo. So in this particular case, what happened was I did not get an IP address in there. Probably my network setup is not set up properly to get the IP address inside my Docker environment. The Docker environment also uses the same virtual switch that we use in Hyper-V. So setting up your networking is as simple or as easy as, or as familiar as setting up with the Hyper-V environment. So that was the Docker demo. I'll quickly switch over and talk about the other thing that's useful when we start talking about the modern services. Nano server. So what nano server, so this is the other part of our story when we start talking about the modern infrastructure. Nano server, if you have heard Jeffrey talk about it, is the modern nucleus. That's the new nucleus for Windows Server. This is where Windows Server is heading. It's small. It has a bunch of attributes that we talk about. It's built from a cloud-first re-architecture point of view. It's meant for the infrastructure, so running Hyper-V, running storage, running clustering. It's also the environment in which you write your application. The picture on the side, it's a depiction of what we call is the scale of nano server. It's built to be the just enough operating system. It's a minimum footprint thing. Bare minimum nano server is a pretty empty thing with just the kernel components, and you have to pull in whatever is needed, be it the drivers to run on your platform, be it the drivers to run in a Hyper-V VM environment. It's the ideal environment in which you get to build your application framework. So for example, the demo that I'm going to show you here is I have another VM called the Nano Server VM or the Nano VM. The machine is off. Let me start the VM very quickly. So what's going on here is I've just turned on the VM. As the VM is coming on, look at the file size. So the other thing that I just wanted to call out here was in this file server view, I have the two VHDXs. So one of the bottom one is the server core VHDX. Now, it's unfair comparison because my server core VHDX had the Docker daemon running and a couple of the ASP.NET application installed. So it's 14 gig. I think it's 14 gig.
14 gig.
Yes. And the Nano Server VHDX was 500 meg. That's
500 meg.
A big change. And this particular VM was Nano Server plus Node.js. So I had Node.js in it, and all it did was it started up and started listening on a service. And what I'm doing here is I'm just, in the interest of being all non-GUI thing, Jeffrey just loves this non-GUI thing, I'm just calling a PowerShell invoke web request to try to connect to that thing. And I got. And all it does is, well, maybe not. I am having networking problems. Okay. So the one above that, you should see that when I ran it earlier, it's just a hello world. It's just saying hello world from Node.js. And the main thing that I want to showcase here is the startup time. On my crappy laptop, it came up in a couple of seconds. On a higher end powerful machine, it will be super fast. That particular VM, I've only allocated 128 megs of RAM.
How much RAM?
Need a lot
How
of
much RAM one more time?
That's 128 meg.
128 megabytes of memory.
And that's full Windows. We are not talking containers yet. So now you combine the two, and you have the Nano server running inside a container, running your application. Your application layer is your OS. So the OS that we have built is purpose-built so that it only needs what is needed for your framework. So if your framework is Node.js, that's the size you will see. You don't need anything more than that. You don't need any more services. This is where we are heading towards in terms of ensuring that the environment that you have to deploy and manage is exactly no more, no less than what is needed. So that was pretty much the demos that I had. Quickly moving on, we talked about a bunch of these things. These are the attributes that we have for Nano Server as a modern operating system. Again, there are sessions on Nano Server. Please go attend those to get more in depth on what it means, how do you manage it, how do you take advantage of it. Yes. So is Nano full Active Directory aware? It's Windows Server with all the attributes. You can domain join them. Okay. Yes. Beg your pardon? That has not been handed out. Correct. Wow. Thank you. So, in summary and in closing, the key things, we started off by saying, where are we in the data center? the evolution of data center. Really, one sentence: virtualization is mature. Maturity does not mean deprecated. It has a long life ahead of it, but it is where it is. We have stopped having checkbox wars with VMware. I keep getting asked the question, hey, VMware has this capability called fault tolerance. They have this capability called hot out of CPU. And my response is, if our customers say that's important for them, we will build them. We will do whatever is needed to ensure that virtualization as a platform continues to evolve and grow. But the primary focus for us is to use that as a stepping stone to build cloud services. So all the innovation that you saw here, from containers, from nano server, from assurance, and all the other capabilities, the rolling updates, it's all to serve this one purpose of ensuring that you have the right services. Clouds, it opens up opportunities, but there are concerns there, and that's the topmost of our mind, to reduce the friction from taking you from where you are to the cloud world. The cloud could be on-prem, the cloud could be on your local hoster, or the cloud could be Azure. Doesn't matter. We want to make sure that your developers get to write services that run to the Microsoft cloud and not be locked in an early decision saying, oh, it has to be the public cloud. Oh, no, it has to be the private cloud. There's no such thing. We want to take away that constraint from your developers and from you, and essentially give the control back to you, saying you get to offer your developers all the flexibility of the cloud, but with your control in it. So when businesses, you represent your businesses, your compliancy, when the business looks at it and say, how did you allow that? Well, now you have a way to say, we ensured that our development environment was modern and they had everything, all the tools they needed. So we gave them the environment and we have the control over it as well. So we can enforce policies. We can choose to say a service that's written, the next generation service that's written in your environment gets deployed privately or publicly. And the final thing is, start looking at this. It's not everyone might be jumping to this services world starting tomorrow, but this is a great time to start having the conversations. Microsoft is investing in ensuring that all frameworks run well. And the demo that I showed about Node.js is not something that you probably would have seen a few years back, where it's like, Microsoft promoting open source, really? But now we are. We are really letting you guys decide what is best for your environment. And maybe the best thing might not be a complete Microsoft runtime environment, and that's perfectly okay. We want you to have the choice, but we guarantee that a Microsoft end-to-end stack will have the best experience possible with the right tooling. So with that,
make sure that you're downloading, taking a look at Windows Server TP2. That's available. System Center Technical Preview is coming very soon, later this week. And make sure you take a look at the Microsoft Azure Infrastructure Services today, because they're going to help prepare you for when Azure Stack comes. I've had a lot of people coming up to me yesterday at the booth saying, oh my gosh, I want to start playing with Azure Stack now. I want to do that. What can I do? Go start playing with Azure right now, because guess what? That's what Azure Stack's going to be. So you can start getting used to plans, services, quotas, resource providers, building new applications that run on Azure, because they will run in Azure Stack in your data center as well. Here's the overview sessions. We just finished up the data center virtualization. Don't forget the networking overview, storage, security, and assurance overview. That'll dive into shielded and guarded VMs more. What's new in System Center and Linux on Microsoft platform. One last thing I want to point out is the Ignite Azure Challenge sweepstakes. If you attend sessions and activities, track your progress online, and enter this session code online. 1B6V. 1 Bravo 6 Violet. All right.
Thank you very much.
Thank you guys very much, and enjoy the rest of the time this week.
Yes.